How is an electron in this flower the same as an electron in this keyboard, or even an electron across the universe? They came from very different places, so how did the universe ensure that they're exactly the same mass and charge? Well, what if all these electrons are part of some unified object, a field? This is exactly how quantum field theory, or QFT, models our universe.
Here's space-time with two space dimensions and one time dimension. A field is basically where you assign a mathematical object to each point in space-time. So this could be scalars, vectors, or something even more complicated like spinors. Now, let's keep things simple and just look at scalar fields where we assign a number to each point in space. To make this quantum, we're going to make this field fuzzy. Just like how you don't know where an electron is in an atom before measuring it, we don't know what exactly the field is before measuring it. So this converts our scalar field into a quantum field. Now let's do something interesting with our quantum field. So you may know that electrons have discrete energy levels, and this discreteness is one of the main features of quantum mechanics. So let's add discrete energy levels to our quantum field. So it currently has energy 0, but we can bump this energy up using something called a creation operator. So adding it to our system, we get a particle. In QFT, a particle is really just a disturbance in our quantum field. Now we can use different creation operators to add particles with different positions and different momentums.
Now imagine you have two electrons. To figure out how they're going to interact, we can draw something called a Feynman diagram, and it's basically a really efficient way of representing the complicated math of QFT. Each Feynman diagram is a possible interaction, and the math gives us a special weight for each one called a probability amplitude. To figure out what actually happens, we take a weighted average of all the interactions. For the two electrons, this average turns out to be that the electrons repel each other. This is what we see in real life as the electromagnetic force, and this is one of the main ways quantum field theory is able to model the world around us.